Okay, we're going to be looking at solving inequalities by adding or subtracting first. And here are our objectives. If you want, you can pause and read through those quickly. Solving one-step inequalities is much like solving one-step equations. To solve an inequality, you need to isolate the variable using the properties of inequality and inverse operations. For example, to solve an inequality that contains multiplication or division, undo the operation by dividing or multiplying both sides of the inequality by the same number. Let's first look at solving by adding or subtracting. Here are some notes on addition and subtraction of inequalities. You can add and subtract the same number from both sides of an inequality and the statement will still be true. A helpful hint: use an inverse operation to undo the operation in an inequality. If the inequality contains addition, use subtraction to undo the addition. So subtraction is the inverse of addition and vice versa. And what would the inverse of multiplication be? Of course, division, and vice versa. All right, so for example 1, what I want you to do is just pause your video for a minute, work this on your own if you can, and then come back to the video and let's see if you got the correct answer. So we're going to solve this inequality. X plus 12 is less than 20. Since 12 is added to x, subtract 12 from both sides to undo the addition. That's our inverse operation. And so x can be any number that's less than 8. And remember, this means x cannot be equal to 8. It can only be numbers that are less than 8. All right, and then on our number line here, are we going to have an open or a closed circle? All right, we're going to have an empty circle is what they use here. Empty circle at 8 because there's no equal to. And the arrow will cover, the shading will cover all numbers that are less than 8. All right, again, pause the video, work on this one alone, and come back to see how you do. Solve the inequality and graph the solutions. All right, so we have d minus 5 is greater than negative 7. So we're going to use our inverse operation, and the inverse of subtraction, of course, is addition. So we're going to add 5 to both sides, and we get d is greater than negative 2. All right, and then for the graph, again, we're going to have an empty circle or open circle at negative 2, and our shading will cover all the numbers that are greater than negative 2, pointing to the right. Okay, and here's a third example. Solve the inequality and graph the solutions. All right, since 0.3 is subtracted from n, add 0.3 to both sides to undo the subtraction. This is the inverse operation. Okay, so we get 1.2 is greater than or equal to n. You can also say that as n is less than or equal to 1.2. And when you're graphing here, you're going to use a solid circle on 1.2 because it can be equal to, n can be equal to 1.2. And then you're going to shade all the numbers that are less than 1.2. And if it helps you guys, rewrite this, and I showed you on your last video, but I'll show you again here. You can rewrite this as n is less than or equal to 1.2. Some of you would probably prefer to see it written that way, and that's fine. Let's erase and go back. Okay. Solving inequalities by adding or subtracting. Since there can be an infinite number of solutions to an inequality, it is not possible to check all of the solutions. You can check the endpoint and the direction of the inequality symbol. The solutions of x plus 9 is less than 15 are given by x is less than 6. So here, you can check the endpoint, substitute 6 for x in the related equation. This time they're using an equation rather than inequality. X plus 9 equals 15. The endpoint should be a solution to the equation. Now, if you substituted that 6 into the actual inequality, it's not going to be a solution. So be careful with whether or not you're using the equation or the inequality here, okay? And the reason it would not be is because we've got a less than and not an equal to. And for step 2, check the inequality symbol. Substitute a number that is less than 6 for x into the original inequality, and the number you choose should be a solution of the inequality. All right, example 2, problem-solving application. Sammy has a gift card. She has already used $14 of the total value, which was $30. Solve and graph an inequality to show how much more she can spend. First, we want to understand the problem. The answer will be an inequality and a graph that show all the possible amounts of money that Sammy can spend. List important information. Sammy can spend up to, or at most, $30. Sammy has already spent $14. Make a plan. So let's write an inequality. Let G represent the remaining amount of money Sammy can spend. All right, so the amount remaining plus the amount used is at most. That means that amount of money has to be less than or equal to 30 because she cannot spend over $30. That's all she has. All right, G plus 14 is less than or equal to 30. All right, and then we want to solve here, which you can do. Going to subtract 14 from both sides, and you should have G is less than or equal to 16. And to graph, we're going to put a solid circle at 0 and 16. Well, why 0? Because before we were just using the 16 or the number, well, can she spend more than she has? No. So the amount of money that she has to spend is between $0 and $16. The amount spent cannot be negative. All right, and then you can check. Sammy can spend from $0 to $16. All right, here's an example for you to try. So pause your screen for a minute, or pause the video, excuse me, and try to work on this one on your own, and then come back and see if you get it right. So we have Mrs. Lawrence wants to buy an antique bracelet at an auction. She is willing to bid no more than $550. So far, the highest bid is $475. Write and solve an inequality to determine the amount Mrs. Lawrence can add to the bid. Check your answer. Let X represent the amount Mrs. Lawrence can add to the bid. So our plan here is $475 plus the amount can add, X, is at most $550. All right, and then solve. Subtract 475 from both sides, and you have X is less than or equal to 75. So they're checking the endpoint. Looks good. Checking a number that's less than 75 to make sure we get a true statement. Yes, we do. Miss Lawrence is willing to add $75 or less to the bid. All right. We're switching now to multiplication and division. And there's a little extra that we need to learn here. You can multiply both sides of an inequality by the same positive number, and the statement will still be true. And also with division, you can divide both sides of an inequality by the same positive number, and the statement will still be true. All right, so let's look at an example here where we're dividing by a positive number. We have 7x is greater than negative 42. Well, 7 and x are multiplied. That's 7 times x. So our inverse of multiplication, of course, is division. So to isolate our variable x, we're going to have to divide both sides by a positive 7. So we end up with x is greater than negative 6. And our graph, open circle or empty circle on negative 6 and then shade to the right. All right, example B. All right, we have 2.4 is less than or equal to m over 3. Now m is being divided by 3. So our inverse operation for division is multiplication. So we need to multiply both sides by 3 in order to isolate the variable m. Okay, so we get 7.2 is less than or equal to m, and again you can rewrite that as m is greater than or equal to 7.2. This time we're going to have a solid circle on 7.2, and we're going to shade all the numbers to the right. And here's a third example for you to try. We have 3/4 r is less than 12. This time we're actually going to multiply by the reciprocal of 3/4, which is 4/3, because 3/4 times 4/3 just gives you 1. So that will isolate the variable r. And remember, if you multiply by 4/3 on the left side, you must also do that on the right side. And so you end up with r is less than 16. And then you have your graph. Open circle on 16 and all the values to the left of 16, or less than. If you multiply or divide both sides of an inequality by a negative number, the resulting inequality is not a true statement. You need to reverse the inequality symbol to make the statement true. Guys, this is for multiplication and division. Both operations, if you divide or multiply by a negative number, you must reverse the inequality symbol. This means there's another set of properties of inequality for multiplying or dividing by a negative number, which I believe you have on your notes sheet there. Okay, and it's just showing you that when dividing by or multiplying by a negative number, you're going to reverse your symbol. Caution, do not change the direction of the inequality symbol just because you see a negative sign. This is important. You only change the direction of that symbol if you're dividing or multiplying by a negative number. Okay, we wouldn't do it in this example here, 4x is less than negative 24, because you're dividing by a positive 4. Okay? All right, here we have an inequality, negative 12x is greater than 84. So x is being multiplied by negative 12x, so we use the inverse operation of division. So when we divide both sides by a negative 12, oh, there we go, dividing by a negative, you must reverse your inequality symbol. So greater than becomes the less than, and we have x is less than negative 7. And graphing is the same. All right, next example. Pause your video for a minute and try to do this one on your own. All right, so we have the inequality negative 8 is less than or equal to x divided by negative 3. Since we're dividing by negative 3, our inverse operation is going to be multiplication, and we're going to multiply by a negative 3 in order to isolate our variable here. And multiplying by negative 3 also constitutes reversing your sign, or your symbol, sorry. And so we end up with 24 is greater than or equal to x, or you can switch that around if you want. X is less than or equal to 24. Again, your graphing's the same. All right, application exercise. Jill has a $20 gift card to an art supply store where 4-ounce tubes of paint are $4.30 each after tax. What are the possible numbers of tubes that Jill can buy? All right, we're going to let P represent the number of tubes of paint that Jill can buy. So we have $4.30 times the number of tubes is at most, so this has to be less than or equal to the $20 she has. The $20 gift card, excuse me. All right, so here's our inequality. And we're going to divide both sides by $4.30, and that's a positive number, so we don't move or switch or reverse our inequality symbol at all. Does not change, just simply divide. And you have P is less than or equal to 4.65. So since Jill can buy only whole numbers of tubes, she can buy 0, 1, 2, 3, or 4 tubes of paint. Okay, 5 tubes would not work, because that would put her over the $20. Here's a lesson quiz. If you want to maybe go through some of these, make sure you can get these answers, and pause your screen and then come back if you need to. All right, thank you.